So welcome again to some more practice. So looking at number one, I could see that this is a product rule because you have two functions being multiplied by each other. So the product rule says that you have u, derivative of u times v plus plain old u times the derivative of v. And this should be y equals to. So y prime is going to equal to a derivative of u, right, which is just 3x squared, times plain old v, which is just e to the x, plus plain old u, which is just x cubed, times the derivative of v, which is just also e to the x. Right? So multiplying them together, our y prime is going to equal, 3x squared e to the x plus x cubed times e to the x. And this will be our answer for number one. Let's look at number two. This is, again, a difference, a quotient rule. And the quotient rule says that the derivative of u times v plus u times the derivative of v all divided by v squared. And this is a mistake. This should be minus. Instead of a plus sign, that should be a minus sign. So following the rules, I could label this as u, this is v. So y prime is going to equal, the derivative of e to the x is just e to the x times plain old v, which is just s, minus plain old u, which is e to the x, times derivative of v. Well, derivative of x is 1. Derivative of any variable is 1. So this is just 1 all over s squared. Alright, so y prime is now equal to e to the x times s minus e to the x all divided by s squared. And this should be your answer. Let's look at number three. Again, this is a quotient rule. And so this is u, this is v. So y prime is going to equal derivative of u, this whole thing right here, which is just 3x squared, derivative of 7 is a 0, right, times v, which is just x, right, minus plain old u, which is just x cubed plus 7, right, times the derivative of v, which is just 1, right, all divided by x squared. And remember, we're using this rule right here. Alright. So doing our little thing right here, y prime is going to equal 3x cubed, because these x squares become cubed. And we're going to distribute this minus sign here, so this is minus x cubed, right, minus 7. Alright, anything times 1 is just itself, so this 1 really doesn't matter. Alright, divided by x squared. Alright, so really now, y prime is going to equal, 1x squared has become 2x cubed, because you minus 1 of this from this, right? And then this becomes a minus 7 all over x squared. Alright, so that will be your answer. Now, if we want to simplify this more, we could just split it apart, alright? This is your answer, but I'm just saying if you wanted to simplify this, could be 2x cubed over x squared minus 7 over x squared, alright? These 2 goes to 1. This leaves an x, right, because that's 3. So really, the more simplified answer would be, 2x minus 7 over x squared. This y prime. This is an answer. This is also an answer. This is a more simplified version of it. Let's look at this one. Interesting enough. Y to the 2x. Well, we said the derivative of y, derivative of e to the x is actually just e to the x, but derivative of e to the 2x is actually not e to the 2x. Typically with these type of problems, without using a chain rule, you're going to have to split them apart. So get used to this. I'm going to split these two x's apart. I could also rewrite this as e. You want to make it a product, basically. How could you make this a product? Well, if I have e to the x times e to the x, right? You see, this is the same thing as e to the 2x. And so without using the chain rule, you have to always find, some sort of way to get these type of problems into a product. It's the same thing if you had, e to the 3x or e to the 4x. You have to find some way to get them apart. So, I would split e to the 3x as e to the 2x times e to the x. And the same thing for e to the 4x. So anytime you see functions like this, you want to split them apart to get product. And what do I mean by that? Now I could go ahead and use my product rule on this, right? Because this is u and this is v. So y prime is now derivative of u, which is e to the x, times e to the x, because we're just multiplying that by plain old v, right? Plus, plain old u, which is e to the x, times the derivative of v, which is just e to the x also, right? So interestingly enough, y prime is equal to e to the 2x, right? Because remember, when we have the same bases, what we do to our exponents, we add them, right? So this is just e, same basis, we just add the exponent, which is e to the 2x, plus e to the 2x, right? So interestingly enough, y prime is actually equal to 2e to the 2x. Why? Because we have two of these, you see? So we have 2e to the 2x. So this is our answer. So anytime you're given some exponential function like this, you want to split them apart to make products. Let's look at this one. All right. So again, quotient rule for these two individually. So the derivative of a constant is just 0, all right, times plain old 3x squared, all right, and then we're gonna minus that from 1, because 1 is just u again, times the derivative of v, which is just 6x, all right, all divided by 3x squared, all right, and we're gonna subtract that from the same thing again, all right, which is just 0. Derivative of 5 is 0, times plain old 2x, all right, minus 5, plain old 5, times the derivative of v, which is this, which is just 2, all right, derivative of 2x is just 2, all divided by 2x squared. So you can see, put a parentheses there to make sense. So you could see this side corresponds to over here. This side corresponds to right here. So anything times 0 is just 0. So this is 0. This is 0. All right. So y prime now equals, negative 6x over 3x squared. All right. I'm going to subtract that from, negative 5 times 2 is just negative 10. All right, so this is negative 10. All right, all over 2x squared. All right. So y prime is now equal to, here we multiply our exponent. So 2 times 2 is 4. All right, we multiply our exponent, so negative 6x over 3x to the 4th power, all right? We distribute this negative, so this becomes a plus 10 over 2x squared. And obviously, we could simplify this more, so we could simplify this 2 and 3, this 6 and 3, so this becomes negative 2x over x to the 4th, right? Plus 5 over x squared. And now we could also take one of these x's away, but because so we could take one of these x's away. So y prime is now negative 2 over x to the 3rd, right, plus 5 over x squared. This will be your most simplified answer, but any one of these answers right here will work. Let's look at the last one. Last one is pretty much easy. It's one of the first things you'll probably see when talking about derivative, and so y prime is now negative 2x. That will be your answer.